Hello fans, once again we are attacking this problem, and this is pretty big. I think it's the kinematic analysis now of the truss here. So what we could do is we could get the bar forces graphically with no statics whatsoever, and we could repeat that for each bar, no problem. And then we can apply the FL over EA equation for each bar. So the only subtlety is that initially I magnified that deformation just so that I could see everything. So I magnified the stretch. So I know the stretch of each bar, but I'm grossly making it larger. So here's the first line. I'm starting at the pin because that's fixed. Here's my original axis, and I'm stretching that bar by FL over EA. Of course, magnified by some arbitrary number. Then, from that point, that's not the new crown. What I need to do is drop the final R somewhere on the horizontal and draw a new circle around that, and that radius will be RC plus delta RC magnified. Okay, so that's what I'm doing here. So I put that circle around here, and that's this original length plus the magnified stretch. And then that crown sits somewhere on the intersection of these 2 points here. So there's the one circle, there's the larger circle, and the final crown is there, but it depends on R. And just as before now, we just move sequentially. So let's find D, which is the point at the bottom here, this point here. So D is the intersection of two circles. It's the lower chord here, which would be LD plus delta LD magnified. That's the radius of this circle. And then this circle is from the crown, and that will be CD plus the magnified deflection. And that's the final D somewhere on there, but of course it depends on R. And then our last step is, as we did in the statics, we draw our final circle around final D. The radius of that final circle is this bar length from D to R. And that ensures, D to R plus delta dr magnified. And then I can do exactly what I did before in the equilibrium part. I have my circle here, and then I simply move this point until it lands on the circle, and I can get as close as I want. Get as close as I want. There we go. And the final deflection here, I get 0.6764 going down for the final D, and that is what I get here, 0.69 in SAP. So kind of unbelievable.